In this last video, we are going to find the current and voltage in each of these resistors and express our answer in a chart as we've done before. I've already created a chart here, and as I mentioned on the first video, I had already pre-labeled each of these resistors with letters. I'm going to start by filling in the resistance of each lettered resistor in my chart. And notice that at the top of my chart here, I already indicated that each resistance is in kiloohms. That's going to be important when you're doing any calculations for this chart, so don't forget about that. As before, I have also included a row for the battery, and the battery has a voltage of 20 volts. In that row for the battery, I always write the equivalent resistance. So looking back at my previous slide, it is 25.59 kiloohms. I'll now calculate the current that is responsible. Again, don't forget that 25.59 is kiloohms when you're calculating the current. I end up getting 7.816 times 10 to the negative fourth. Now it's time to start finding voltage and current for each resistor. So I look back at my very last picture that I drew, all the way at the bottom of this page. I have two resistors in this picture, and the two resistors are in series with each other. That means that they have the same current, and the current that travels through them is the same current that travels through the battery. So the current traveling through each of these is 7.816 times 10 to the negative fourth amps. In the past, some students have found it advantageous to arrange the current and voltage for these combination resistors in a chart as well. And you may choose to do that. That is perfectly fine. Now we'll find the voltage for each of these two resistors by multiplying that current times their resistance. Again, don't forget that they're in kiloohms. So the voltage through DGHCEFI, quite a mouthful, is 8.277 volts. And the voltage through AB is 11.724 volts. I know everything I could possibly know about this picture, so I'm going to move up one picture. And I notice the difference here is that DGH and CEFI are separate. Because we combine DGH and CEFI in parallel with each other, they have the same voltage as DGH-CEFI. In other words, their voltage is 8.277 volts. I will now use Ohm's law to calculate the current. For CEFI, I get 4.139 times 10 to the negative fourth amps. And for DGH, I get 3.679 times 10 to the negative fourth amps. I know everything I could possibly know about each one of these resistors now. So I can move up a picture. Here, CEF and I are separate. We combined CEF and I in series to get resistor CEFI, which means that they have the same current as the current that travels through CEFI. In other words, their current is 4.139 times 10 to the negative fourth amps. Because I has only a single letter, it belongs in my final answer chart. So I'm going to write that number in this final answer chart. Oh, I apparently forgot I in my final answer chart. But I have a J in there. I must have just miswritten that. Instead of an I put a J. So I'll just go ahead and erase that. And write the letter I here. And as I said before, its current is 4.139 times 10 to the negative fourth. I can now calculate its voltage by multiplying that number, 4.139 times 10 to the negative fourth, times 15 times 10 to the third. I get a voltage of 6.208. Again, if you're doing this along with me and your numbers are slightly different, that's okay. It could just be a rounding thing. Going back to my picture here, I know everything I can know about I know everything I can know about DGH, I know everything I can know about AB, but I don't know the voltage for CEF. So I'm going to calculate that right now. I get a voltage, wrong color. I get a voltage of 2.069 volts. I now know everything about each resistor here, so now I go back one picture. In this picture, you notice D and GH are separate. And they're in series, so they're going to have the same current as resistor DGH. DGH had a current of 3.679 times 10 to the negative fourth amps. D is a single letter resistor, so I can move over to my chart. And I will now calculate the voltage across that resistor. I get 7.358. Going back to my picture here, I know everything I can know about D. I don't know everything I can know about GH. So I need to find the voltage across GH. I get that voltage is 0.9198. 0.9198 volts, or 0.920 if you want to round a little more. Now I know everything I could possibly know about every resistor in this picture, so I move up a picture. CF and E were combined here, and they are in parallel. That tells me they have the same voltage as resistor CEF. So I'm going to go back to a picture that has the voltage for CEF, and I see that it was 2.069 volts. So each of these are 2.069 volts. E is a single letter resistor, so I can write 2.069 volts on my chart. And then I can calculate the current. I get 2.069 times 10 to the negative fourth. I need to know the current through CF. And since CF and E have the same resistance, the current through CF will also be 2.069 times 10 to the negative fourth amps. Moving up a picture, you'll see that A and B are now separate. They are in series, so this have the same current as resistor AB. And resistor AB has a current of 7.816 times 10 to the negative fourth amps. .816 times 10 to the negative fourth amps. I'll write that for A and B on my chart. Now I need to find the voltage. For B, the voltage is just 7.816. For A, the voltage is 3.908. Going back to my picture, I know everything I can possibly know about this picture now, so I move up one, and I see that G and H are separate. And G and H were in parallel, so they have the same voltage as resistor GH. Going down, I see that resistor GH was 0.9198 volts. So I'm going to go ahead and write that on my chart for G and H. 0.9198. I can calculate the current now by dividing that number by 5 times 10 to the third. And the current through both of them is 1.840 times 10 to the negative fourth. Down to two resistors left. The last two are C and F. They were in series, so they have the same current as CF. 2.069 times 10 to the negative fourth amps. And then I can calculate their voltage, which is 1.035. If you have any questions, please ask me in class.